What's wrong, Michael?
Who's that?
It's Nick from geometry class.
Oh, Nick. Just the person I was looking for. You see, I had trouble with the lesson today.
You mean the ones about parallel lines and proportional parts?
Yeah, that's the one.
Here, I can help you. Let's go upstairs and I'll show you some key definitions and theorems.
Sounds like a plan.
Important definitions and theorems. Parallel lines. Coplanar lines that do not intersect. Proportion. An equation of the form A over B equals C over D. Midsegment of a triangle. A segment with endpoints that are the midpoints of two sides of a triangle. Triangle proportionality theorem. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional length. Converse of triangle proportionality theorem. If a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then the line is parallel to the third side of the triangle. Triangle midsegment theorem. A midsegment of a triangle is parallel to one side of the triangle, and its length is 1/2 the length of that side.
Sounds like a lot of...
Hoopla!
Sounds like a lot of...
Hoopla!
Sounds like a...
Hoopla! Hoopla!
Sounds like a lot of hoopla to make a...
Parallel lines of proportional parts.
But Nick, I'm still confused.
Here, let's go back upstairs and I'll show you an example. In this picture, ST is parallel to RQ. PT equals 7.5, TQ equals 3, and SR equals 2.5. We're going to find PS. First, because of the triangle proportionality theorem, PS over SR equals PT over TQ. Then we can substitute the values we know. So PS over 2.5 equals 7.5 over 3. Now we're going to cross multiply, so it's 3 PS equals 18.75. Then we're going to divide each side by 3, and we'll get PS equals 6.25. And that is the answer.
Alright, I think I'm starting to understand now. But how can this be applied to real life?
I'm glad you asked. Let's go outside and I'll show you. Using the converse of the triangle proportionality theorem, we can find out if these fence posts are parallel. Using a random fence post, this one, we're going to find out if the segments it makes are proportional. So we measure the first segment, which is 36 inches. And we measure the second segment, which is 22.5 inches. And we measure the third segment, which is 25 inches. And we measure the fourth segment, which is 40 inches. And now we're going to take it back inside, and Michael's going to see if he can do this himself.
Okay, we know that this side is 40 inches. And this side is 36 inches. This one is 22.5 inches. And this one is 25 inches. So we can find out if these two lines are parallel, the two fence posts, by cross multiplying. So we would do 25 over 40 equals 22.5 over 36. And we're going to cross multiply using this nifty TIN spotter. So 25 times 36, 900 equals 40 times 22.5, 900. And it's true. So these two lines and all the rest of the fence posts are parallel.